Welcome to Khetz tutorials, and in this video I'll be covering question 35 from 1.1 exercises in James Stewart calculus. So you're asked to find the domain of this. If you just had the bottom part, we'd quickly say that this portion just has to be 0 or positive. So if this is 0 or positive, then this function is defined and we would be done. But this is underneath 1, so it's a fraction. So we can't have it as 0 because the fourth root of 0 would give us 0. Then we'd have division by 0, which we don't want to have. So we're going to follow the same approach, but we're not going to include the 0. And the same applies for any other even root. So for all even roots, your condition would be greater or equal to 0, but you now also have to look at the placement of your root. If it's below, if it's in a fraction, then you don't want the bottom part of the fraction to be 0. If it was above, then it can be 0. In this case, it's below, so x squared minus 5x has to be greater than 0. So this has to be positive so that the bottom part can exist. Once we have a value there, it will divide the 1 or it will get into the 1. The whole function will be defined. So as long as this condition is satisfied, then your function will be defined. And this will give you all of the x values where the function is defined, which is the definition of your domain. So now let's solve this. So you'd factor out x, have x minus 5 greater than 0. Your critical values, so I like using the number line method. There are quite a few ways you can use. You can use the graph, you can use a bunch of other methods. I like using the number line method to find the domain. So to answer this, then my critical values would be 0, because if you were to solve, one of your solutions would be 0, the other would be 5. So now I'm going to draw a number line. And this number line will help me to figure out where I have positive and negative values. And this will just be from picking a number to the left of 0, in between 0 and 5, as well as to the right of 5. So just by picking one number in those regions, I can figure out whether the numbers in that region are positive or negative. And I want the regions where I have positive answers based on my condition there. So you're going to look at the condition which you set out in the beginning. Then you're going to test each of the regions, then give the regions which match your condition as the final answer. So to the left of 0, I can pick minus 1. So if I pick minus 1 and substitute it in here, then I'm going to have minus 1, minus 1, minus 5. So this is minus 1, and in here I'm going to have minus 6 multiplied. So I'm only interested in the sign and not really the number, but you can find the number. So minus 6 multiplied by minus 1 is just be 6, which is positive. So this region gives a positive result. Let's look at the region between 0 and 5. Let's pick a number in there, let's say 3. Any number between 0 and 5, and any number in any of the regions. So if you pick 3, then you're going to have 3. So substituting into this once again, you're going to pick 3, and 3 minus 5. So this portion is negative. Negative multiplied by positive lead to a negative. So this region here is negative, and it does not match that. So you can't give this region between 0 and 5 as our answer. Finally, let's assess the last region, which is to the right of 5. So you can pick any number once again. If we pick 10, just as an example, so any number, then this is positive and that is positive. Two positives multiplied would give us a positive. So this region is also positive. So we're going to take the two regions that match what we're looking for. So we want our function, we want this portion to be positive. So that is satisfied to the left of 0 as well as to the right of 5. So this will be your domain, and this is how you can give your domain. Another way to give this will be x is an element of minus infinity to 0 union, then from 5 to infinity. So this is another way to give your answer, which basically means the same thing.